Hello, welcome to Cloud Learning channel. In this module, we will talk about all Google Cloud BigQuery top interview questions and answers. Let's start with the question 1. What is BigQuery? BigQuery is a fully managed enterprise data warehouse that helps us manage and analyze our data with built-in features like machine learning, geospatial analysis, and business intelligence. A BigQuery's serverless architecture lets us use SQL queries to answer our organization's biggest questions with zero infrastructure management. So we don't have to worry about managing any infrastructure. We don't have to worry about underlying software. So BigQuery's scalable distributed analysis engine lets us query terabytes in seconds and petabytes of data in minutes. And BigQuery maximizes flexibility by separating the compute engine that analyzes our data from our storage choices. And we can store and analyze our data within BigQuery or use BigQuery to assess our data wherever it exists. So BigQuery interfaces include Google Cloud Console interface and the BigQuery command line tool. If you are a developer or if you are a data scientist, you can use the client libraries with familiar programming, including Python, Java, JavaScript, and Go, as well as BigQuery's REST API and RPC API to transform and manage data. If you are a data analyst or data engineer or data warehouse administrator or a data scientist, the BigQuery ML documentation also helps to discover, implement, and manage data tools to inform critical business decisions. How does BigQuery work? Let's talk about these three: BigQuery storage, analytics, and administration. BigQuery stores data using a columnar storage format that is optimized for analytical queries. A BigQuery presents data in tables, rows, and columns, and it provides full support for database transaction semantics. A BigQuery storage is automatically replicated across multiple locations to provide high availability. What about BigQuery analytics? Let's talk about BigQuery analytics. Descriptive and prescriptive analysis uses include business intelligence, ad hoc analysis, geospatial analytics, and machine learning. So we can query data stored in BigQuery or run queries on data where it lives using external tables or federated queries, including cloud storage, Bigtable, or Cloud Spanner or Google Sheet stored in Google Drive. Let's talk about BigQuery administration. BigQuery provides a centralized management of data and compute resources, while IAM helps us secure those resources with the access model that is used throughout Google Cloud. Google Cloud security best practices also provide a solid, flexible approach that can include a traditional perimeter security or more complex and granular defense in-depth approach. Question 3. What is BigQuery ML? A BigQuery machine learning lets us create and execute machine learning models in BigQuery using standard SQL queries. A BigQuery ML democratizes machine learning by letting SQL practitioners build models using existing SQL tools and skills. So BigQuery machine learning also increases development speed by eliminating the need to move data. So let's talk about the BigQuery ML functionality. So it is available using Google Cloud Console. So you may have a question. So we'll just learn about BigQuery ML. So how do we use it? So if you want to use this BigQuery ML, you can use that service using Google Cloud Console. You can log in, and then you can just go to search and look for BigQuery ML. Then you get a service and just click on it, and that page navigate you to create and how to use that service. But if you don't want to use Google Cloud Console, you can also use BigQuery command line tool, or you can also use BigQuery REST API. So there is external tools such as Jupyter Notebook or Business Intelligence Platform, where you can use this BigQuery ML functionality. Question 4. What is dataset? Dataset is contained within a specified project. So if you want to learn about what is a project, and please go to my other modules, so how to create and what is this project about. Once you create a project in Google Cloud, and where you can keep all your resources in that project, and you get a bill based on that project, and you can enable project or disable for the billing. Okay, so let's come back to dataset. So dataset is contained within the specific project. So datasets are top level containers that are used to organize and control access to our tables and views. Uh, a table or view must belong to a dataset. So we need to create at least one dataset before loading data into BigQuery. Without creating data set, we cannot load any data into BigQuery. So we must create a data set. A data set is just like a schema. So if you're coming from traditional SQL Server or Oracle or something, so you may have a question, what is this data set? A data set is kind of schema. So you can say like a schema. So you can create a table or view under this data set, and if you want to bring, if you want to load data from any external source or from the cloud storage, you must load this data. You have by creating a data set. Without data set, we cannot perform anything. And also, what is the format? We need to use the format, our project name, and then dataset name to fully qualify a dataset name when using Google Standard SQL, or the format project name dot colon a dataset name to fully qualify a dataset name when using the BQ command line tool. And also we specify a location for storing our BigQuery data when we create a data set. So if you want to find what are these BigQuery dataset locations, please go through that Google Cloud Docs, so where you can find all the BigQuery dataset location. And once we create the dataset, the location cannot be changed, but we can copy datasets to different locations or manually move the dataset in a different location. Let's go to question 5. What type of tables are supported by BigQuery? A BigQuery table contains individual records organized in rows. So each record is composed of columns, or we can also call fields. So every table is defined by a schema that describes the column names, data types, and other information. So we can specify the schema of a table when it is created, or we can create a table without schema and declare the schema in the query job or load job that first populates it with data. And what are the table types the BigQuery supports? The native tables, so tables backed by native BigQuery storage that includes standard tables, table clones, table snapshots, materialized views. And what are the other types of tables supported? External tables and views. So let's talk about external tables. Tables backed by storage external to BigQuery. And views are virtual tables defined by a SQL query. Let's go to question 6. What is partition table? A partition table is a special table that is divided into segments called partitions that make it easier to manage and query our data. So when we are running query, if you are querying against a big table, if you mention a partition table, so when you mention that partition column in your query, then it eliminates the remaining partitions so that you can get the results quick. So the partition is a little important. So we will discuss more about this partition in a big query in next 2-3 questions. Let's talk about that partition again. So partition table is a special table that is divided into segments called partition that make it easier to manage and query our data. By dividing a large table into smaller partitions, we can improve query performance and we can control a cost by reducing the number of bytes read by a query. Okay, so let's go to next question. We'll talk more about this partition table. How do you partition a BigQuery tables? You can partition BigQuery tables by time unit column, ingestion time, and integer range. So let's talk about time unit column. So tables are partitioned based on a timestamp or date time column in the table. So that is called time unit column. So if the table is partitioned based on a timestamp, date time column in the table. And what about the other partition? So other partitions are ingestion time and integer range. So in ingestion time, the tables are partitioned based on the timestamp when BigQuery ingests data. Let's talk about integer range. Tables are partitioned based on an integer column. So if a query uses a qualifying filter on the value of the partition column, BigQuery can scan the partitions that match the filter and skip the remaining partitions. So this process also called as pruning. What is partition pruning? So we just talked about a pruning. So now let's talk about partition pruning. If a query uses a qualifying filter on the value of the partition column, so this BigQuery can scan the partition that match filter and skip the remaining partition. So we just discussed about this, and this process is called partition pruning. What is partition pruning? Partition pruning is the mechanism BigQuery uses to eliminate unnecessary partitions from the input scan. So the pruned partitions are not included when calculating the bytes scanned by the query. So in general, partition pruning helps reduce query cost. Pruning behaviors vary for different types of partitions. So we could see a difference in bytes processed when querying tables that are partitioned differently but are otherwise identical. What are the best practices for partition pruning? Use a constant filter expression, isolate the partition column in our filter, or require a partition filter in queries. So let's talk a little bit details about these best practices. Let's talk about first one, use a constant filter expression. To limit the partitions that are scanned in a query, so we use a constant expression in our filter. So if we use a dynamic expression in our query filter, so BigQuery must scan all of the partitions. Let's talk about isolate the partition column in our filter. Isolate the partition column when expressing a filter. So filters that require data from multiple fields to compute will not prune partition. Let's talk about a small example. A query with a date comparison using the partition column and a second field, or queries containing some field concatenations will not prune partitions. Let's talk about the last best practice, require a partition filter in queries. When we create a partition table, we can require the use of predicate filters by enabling the required partition filter option. So when this option is applied, attempts to query the partition table without specifying a where clause produce an error. So what is that error? That error is like, it cannot query over table, project and data set and table without a filter that can be used for partition elimination. Let's talk about question 10. What are cluster tables? Cluster tables in BigQuery are tables that have a user-defined column sort order using a clustered columns. Cluster tables can improve query performance and reduce query cost. In BigQuery, a clustered column is a user-defined table property that sorts storage blocks based on the values in the clustered column. The storage blocks are adaptively sized based on the size of the table. So a cluster table maintains the sort properties in the context of each operation that modifies it. Queries that filter or aggregate by the clustered columns only scan the relevant blocks based on the clustered column instead of the entire table or table partition. So when we cluster a table using multiple columns, the column order determines which column take precedence when BigQuery sorts and groups the data into storage blocks. Let's talk about question 11. When to use clustering? We consider clustering in some scenarios. Our queries commonly filter on particular columns. Clustering accelerates queries because the query only scans the blocks that match the filter. And also our queries filter on columns that have many distinct values, unique values. So clustering accelerates these queries by providing BigQuery with detailed metadata for where to get input data. And we do not need strict cost estimates before query execution. And also there are other alternatives to clustering in some circumstances. What are those? We need a strict query cost estimate before we run a query. The cost of queries over cluster tables can only be determined after the query is run. Query tables are smaller than 1 GB. Typically, clustering does not offer significant performance gains on tables less than 1 GB. What is view? A view is a virtual table defined by a SQL query. So in a SQL Server or Oracle, if you're using any other database, so you must be aware of view. The same as view. A view is a virtual table defined by a SQL query. When we create a view, we query it in the same way we query a table in BigQuery. When a user queries the view, the query results contain data only from the tables and fields specified in the query that define the view. Explain the routines in BigQuery. In a BigQuery, in Google Cloud BigQuery, routines are resource type that includes stored procedures, user-defined functions that is called UDFs, including remote function and table functions. So if you want to create a routine, so you can just go to Google Cloud Console and just create a routine or anything. If you want to create a data set, a project, please go to my other videos in the channel. So you can find a lot of videos how you can create project, data set, table, view, or routine. All the details I explained in detail, and I did a lot of exercises on this BigQuery. Please go and watch my other videos that is related to BigQuery in the channel. Let's talk about question 4. Explain the connections in BigQuery. A BigQuery lets us query data that is stored outside of BigQuery in Google Cloud services like Cloud Storage or Cloud Spanner, or in third-party sources like Amazon Web Services or Microsoft Azure. All these external connections use the BigQuery connection API. Example, suppose we store details about customer orders in Cloud SQL, and data about sales in BigQuery, and we want to join the two tables in a single query. So how we can join it? We can create a Cloud SQL connection to the external database by using the BigQuery connection API. So with connections, we never send database credentials as clear text. So what is a connection? A connection is encrypted and securely stored in the BigQuery connection service. We can give users access to connections by granting them BigQuery connection identity and access management roles that is IAM roles. Explain the search indexes in BigQuery. A BigQuery search indexes lets us use Google Standard SQL to easily find unique data elements that are buried in unstructured text and semi-structured JSON data without having to know the table schemas in advance. So with these search indexes, BigQuery provides a powerful columnar store and a text search in one platform, enabling efficient row lookups when we need to find individual rows of data. So a common use case is log analytics. Uh, let's say an example, we might want to identify the rows of data associated with the user for general data protection regulation reporting or to find specific error codes in a text payload. BigQuery stores and manages indexes, so when data becomes available in BigQuery, we can immediately retrieve it with the search function. What are the ways of ingesting data into BigQuery? So there are four ways. There are actually several ways, but here in the question I mentioned uh, four methods: batch load, a set of data records; stream individual records or batches of records; use queries to generate new data and append or overwrite the results to a table. The last one, use a third-party application or service. What is Big Data Transfer Service? The BigQuery Data Transfer Service automates data movement into BigQuery on a schedule managed basis. So our analytics team can lay the foundation for a BigQuery data warehouse without writing a single line of code. We can access the BigQuery data transfer service by logging into Google Cloud Console or using BigQuery command line tool or BigQuery data transfer service API. After we configure a data transfer, the BigQuery data transfer service automatically loads data into BigQuery on a regular basis. So we can also initiate data backfills to recover from any outages or gaps. But currently we cannot use the BigQuery data transfer service to transfer data out of BigQuery. What are the options for batch loading in BigQuery? So we just discussed about the options to load into BigQuery, but what are the options and especially in batch loading? There are several options here. You can see load jobs, SQL, BigQuery data transfer service, BigQuery storage, write API, and other managed services. Let's talk about what is this loading option in batch loading. Load data from cloud storage or from a local file by creating a load job. So the records can be Avro format or CSV, JSON, or Parquet format. Let's talk about second one, SQL. The load data SQL statement loads data from one or more files into a new existing table. We can use load data statement to load Avro, CSV, JSON, or Parquet file. BigQuery data transfer service. We just discussed about it. We use BigQuery data transfer service to automate loading data from Google software as a service apps or from third-party applications and services. What about BigQuery storage write API option? The storage write API lets us batch process an arbitrarily large number of records and commit them in a single atomic operation. If the commit operation fails, we can safely retry the operation. What about the last option here, other managed services? We use other managed services to export data from an external data store and import it into BigQuery. Question 19. What are the options for streaming in BigQuery? So we just discussed about options for batch loading in BigQuery. Now we're going to talk about options for streaming in BigQuery. So here we see that storage write API, data flow, BigQuery connector for SAP. With the streaming, we continuously send smaller batches of data in real time, so the data is available for querying as it arrives. So the options for streaming in BigQuery storage. Let's talk about storage write API. The storage write API supports high throughput streaming ingestion with exactly once delivery semantics. What about data flow? We use data flow with the Apache Beam SDK to set up a streaming pipeline that writes to BigQuery. The last one, BigQuery connector for SAP. The BigQuery connector for SAP enables near real-time replication of SAP data directly into BigQuery. Question 20. What are the types of data sources we can query in BigQuery? BigQuery lets us query there are four types of data sources: data stored in BigQuery or external data, multi-cloud data, and public data sets. Let's talk about data stored in BigQuery. We can load data into BigQuery for analysis. We can also generate data by using DML statements or by writing query results into a table. What about external data? We can query various external data sources such as Google Cloud Storage services like Cloud Storage or database services like Cloud Spanner or Cloud SQL. What about multi-cloud data? So we all know the other cloud providers, AWS and Azure. We can also use that as a source to query in BigQuery. So we can query data that is stored in public clouds such as Amazon Web Services, that is AWS or Microsoft Azure. We can also query from these cloud providers. If you want to know how to query from that, please go to my channel, and there you can find, like, how we can create a connection and how we query data that is existing in Microsoft Azure or AWS. Let's talk about the last one, public data sets. If we don't have our own data, we can analyze some of the data sets that is provided by Google Cloud and BigQuery, and they're all available in public dataset marketplace. Question 21. How BigQuery processes queries? So several processes occur when BigQuery runs a query. There are 5 execution trees: shuffle tier, query plan, query monitoring, and dynamic planning and query results. Let's talk about execution tree. When we run a query, BigQuery generates an execution tree that breaks the query into stages. These stages contain steps that can run in parallel. What about shuffle tier? Its stages communicate with one another by using a fast distributed shuffle tier that stores intermediate data produced by the workers of a stage. When possible, the shuffle tier leverages technologies such as a petabit network and RAM to quickly move data to worker nodes. Let's talk about query plan. When a big query has all the information that it needs to run a query, it generates a query plan. So we can view that plan in a Google Cloud Console and use it to troubleshoot or optimize the query performance. Let's talk about query monitoring and dynamic planning. Besides the workers that perform work of the query itself, additional workers uh, monitor and direct the overall progress of work throughout the system. As the query progresses, BigQuery might dynamically adjust the query plan to adapt to the results of the various stages. Let's talk about the last one, query results. When a query is complete, BigQuery writes the results to persistent storage and returns them to the user. So this design lets BigQuery serve cached results the next time that query is run. Question 22. How do you view the query plan in the Google Cloud Console? After the query is complete, we can view the query plan in the Google Cloud Console. So if you log into Google Cloud Console, you can view it. So you can just request execution details by using information underscore schema dot jobs dot views, or maybe jobs dot get REST API method. By using these two, we can view the query plan in the Google Cloud Console. The query plan includes details about query stages and steps. So that can help you understand how your query is executing in Google Cloud. All these details can help you identify ways to improve query performance. How do we analyze our data with various analytics and business intelligence tools that integrate with BigQuery? We can see the BI tools here: Looker Studio, Connected Sheets, Looker, and Data Lineage. Let's talk about Looker Studio. After we run a query, we can launch a Looker Studio directly from BigQuery in the Google Cloud Console. Then in Looker Studio, we can create visualizations and explore the data that's written from the query. So if you want to get more information about Looker Studio, please go to my channel where I created a module. So in that module, I explained you and I showed you how to connect to this big query from Looker Studio and start building a dashboard, a simple dashboard. Please go to that module and then you can find more details about Looker Studio. Let's talk about the next one, connected sheets. We can also launch connected sheets directly from BigQuery in the console. A connected sheets runs BigQuery queries on our behalf, either upon our request or on a defined schedule. So results of those queries are saved in our spreadsheet for analysis and sharing. What is Looker? Looker is an enterprise platform for business intelligence, data applications, and embedded analytics. The Looker platform works with many data stores, including BigQuery. Let's talk about data lineage. This feature is still in preview, but if you want to get more details about data lineage, please go to Google Cloud Docs so you get more details. So data lineage is a data flex feature that lets us track how data moves through our system, where like where it comes from or where it is passed to and what transformations are applied to. Again, this feature is in preview, so if you want to get more details, please go to Google Cloud Docs and you get more information on data lineage. What is an analytics hub in BigQuery? Analytics hub is a data exchange platform that enables us to share data and insights at scale across organizational boundaries with a robust security and privacy framework. With this analytics hub, we can discover and access a data library curated by various data providers. How do we copy a table's data from a particular point in time? We might want to create copies of our data for various reasons, such as a protection from human error or to retain data for comparison in the future. So the BigQuery provides several options for copying tables data from particular point in time. Let's talk about time travel. We might need to access a table state as it was sometime within past week. Example, if the data became corrupted due to human error. So BigQuery retains historical data for our tables for 7 days. So we can access tables, recent historical data by using the time travel feature. So again, BigQuery retains historical data for tables is 7 days. Let's talk about table snapshots. If we want to be able to access a table state from earlier than 1 week in the past, consider creating table snapshots periodically. So table snapshots are lightweight, read-only copies that let us preserve the state of our tables indefinitely. Let's talk about the last one, table clones. If we want to make a lightweight, a mutual copy of a table, we can use table clone. Again, this table clones is in preview, but if you want to get more details about this table clone, please go to Google Cloud Docs so you can find more details on that. So we covered all top 25 Google Cloud BigQuery questions in this session. If you have any questions about BigQuery architecture or how BigQuery works and how do you create a data sets, tables, partitions, clustering, pruning, or how do you query from external data sources, how do you load a batch loading or streaming loading into BigQuery, or how do you take a backup? And if you have any questions about BigQuery, please do not hesitate to post your questions in the comment section. So I will try to reply as soon as possible. So if you like this video, please subscribe and share the channel. Thank you.